And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today I'm going to show you a little project I've been working on for a change. You may have seen these things on various YouTube channels. This is the Laura Meshtastic node. This is a Heltec one. There are quite a few different ones available. This is running Meshtastic. Now, I experimented with Meshtastic probably 2 or 3 years ago now with the LilyGo T-Beam board. I have one here, but I was on 433 megahertz, which is license free as long as you keep to the duty cycle and power output of these boards. You're quite safe. As a licensed amateur, I think I can now run a kilowatt as of a couple of days ago, but I shan't be doing that. But yeah, these ones are 868 megahertz, made popular by Andy Kirkby, who's really thrown his weight around with those. And at long last, I mean, a couple of years ago, it was only me. I don't think I ever saw another node, so I switched to using the 433 for doing APRS, which was working quite well. Well, my mate Matt's taken his station down temporarily because his mast, I think, is in his garden horizontally. Not good. But anyway, he's working on that. So yeah. Anyway, this 868 business, it's gone mad. There are 20 or 30 nodes I can see now. I'm not going to take you through Meshtastic. Go and watch Andy Kirkby's channels. There are a million other. It's a piece of cake to do. The hardware is reasonably inexpensive. You don't even need any software on your computer to flash firmware onto these things. It's all done via a website. Absolutely brilliant. But yeah, you can get one of these, put it somewhere high up, and you chat on an app on your phone, and good fun. Anyway, what's needed is a bit of a home base unit, and to that end, I've created this. Yeah, so we've got a sort of weatherproof box here. This is a Paradar antenna, and it's of some length. We're getting on for, I don't know, 3/4 of a metre probably. It's quite long. Yeah, so I'm going to mount that up my mast along with my weather station. So we need to fit some hardware in here. I need to drill a hole in the bottom to put some power in, but also these boards, they do have a battery charger on board. So if the power was to fail, this will still work. All the preppers are going to love this. So if you're into doom and gloom, you can enjoy the fun as well while your battery lasts. Now this battery, yeah, it's a homemade one. It's made from those vape batteries that we did previously on the channel. A video actually got demonetized because apparently it's not appropriate content. I think because it's mentioned vaping, and this is probably going to go the same way. But yeah, if you can salvage yourself some batteries, balance them up and put them in parallel. Now, to balance them up, I covered this on my vape battery video, which I shall link in the description below. But I do it by just connecting each cell in turn via a 1 ohm resistor to its brother. I generally do 3 cells at a time and then balance it back with a pack. Hence I need 4 resistors, 4 cells at a time, sorry, and balance it back to the pack. And when you get less than about 10 millivolts across here, you're pretty good shape to short them out. If you just try and bang them all in parallel straight away, you're going to flow a lot of current. Don't do it, folks. Yeah, I think Big Clive took a measurement and it was in the region of many amps. So you don't want to do that. It's going to stress the cell out. 1 ohm seems to be about right. So yeah, inside there we've got 16 cells in parallel, and that's given us about 3.5, nearly 4 ampere hours. So it's pretty good. If you want the 3D printer files for the carrier and the little lids, I shall leave a link in the description below. Yeah, there are a few different size batteries in vapes. I shan't mention the brands of the ones I used because I shan't. Because, yeah, it'll probably get me demonetized, and don't fancy that. Right, This is a Heltec V7 board. I've already flashed it with the correct firmware. I have also loaded, using the app on my phone, loaded the details I want displayed on it. It's called DOS Base. So there we are. I've added a header on there. You see that? There is, just, where are you? You're over there. There's a little header on there. That's going to supply our power externally up the mast. So I just need to fit that. I choose to fit it up here somewhere. Doesn't matter if I can't see the display, because this is going to have a lid on it. So I'm going to mount my battery about there, I think. And that allows me to plug into the bottom of the board. So I think the first thing to do is actually just to bond the battery in to the bottom of the box. And being as I had the silicon gun out, I think I'll do it with that. Right, just wait for that to go off. Right, you can tell by the change of jumper that it's the following day. Off camera, I mounted the mounting plate for the Heltec V3 in the bottom of the case there, again with a blob of silicone while I had it out. And I also realised I hadn't drilled the hole in the bottom. And obviously drilling that way into the case, I was going to risk drilling a hole in my battery as well. So what I actually did was I put that in there and then drilled the case, because we don't want a lithium fire in the workshop. That would be most unpleasant. Right, one thing I have sort of made a mistake with, because I have set this Heltec up already, as soon as I plug it in, it's going to start to transmit. I have removed the RF bits. This, by the way, is an IPX connector. Let's have a look on the top camera. There you go. It's a tiny little IPX connector that connects to the Heltec. It goes into an SMA. Ooh, where are you there? And then an SMA to the N, which fits on the bottom of the Paradar antenna. So that's all well and good, but I'm going to struggle to fit it all in with it all connected. So what I'm going to have to do, because obviously as soon as I apply power via the battery, it's going to power up the Heltec, try to transmit, and we don't want to damage it. So what I'm actually just going to do is take this battery apart. The top should just pull off, he said. Yeah, there we go. There we are. And I'm just going to desolder the positive connection there. So we are off. Happy days. I shall solder that on once it's all up together. I've got a mile of this ordinary, it's actually mains lead. I know we shouldn't use that for 5 volts, but it's mine. I'm not selling it. So that's going to fit in there. We'll stick a blob of sealant around it once it's done. That's going to feed our 5 volts into our Heltec. I'm going to need to put a couple of DuPont connectors on there or something similar. You'll probably have to take the wire gauge down and probably solder a couple of DuPont receptacles onto there, and yeah, we're good to go. So the next thing really, I suppose, is to fit the Heltec in, so I can connect to the battery connector is underneath, which is not the most ideal thing in the world, I have to say, and it's tiny, which doesn't help with my tremor. Right, that's in. I want it sort of that way round. Wires are going to come out of the back like that, in that notch I have created generously, and then we'll just push that home if I can. I've made this bracket purposefully quite flexible so we can bend the sides out so it snicks in. There we go. That's going to hold that in there securely. Right, the next thing to do, I think, is to attach our aerial bits. And hopefully that all clears. It does. That's helpful. Get that in there nice and tight. And then I need to orient our IPX connector Again, not easy when you've got a tremor. By the way, somebody's commented on that the other day. It's not Parkinson's, I'm all right. It's called benign tremor. I've mentioned it several times. And it is nothing other than a huge frustration in my life. So, yeah, unless it ever develops unpleasantly into something else, entirely possible. But, yeah, no, I'm absolutely fine. Just a little bit shaky. Oh, this is all in the wrong orientation. What I'm going to do is I'm going to remove the SMA part here, connect it to the Heltec, and then put it back in. Yep. I bought the Heltec modules actually do come with a pigtail. That's the sort of pigtail it comes with. Can you see the thickness of that coax? Now, as a general rule of thumb, the thicker your coax is, the better it is. And we are running at 868 megahertz. And, you know, you can't use RG58 or something like that for these frequencies. You will just get masses of loss. You can try LMR 400, something like that would do very nicely, but that is a really thick coax. And it's better. That's why I want to mount this up the mast. So I have got, you know, what's that, 20 millimeters? Sorry, about 10 centimeters of coax, 100 millimeters. That's going to keep our losses. The losses are per meter or per foot. If you go onto coax websites from a reputable manufacturer, they will give you losses at certain frequencies. That's the reason RG58 works as a trait for things like ham radio and the HF bands, and to a certain extent CB radio, 27 megahertz, because the losses at those frequencies are quite acceptable for foot. But you want to try running 868 megahertz down it, you're going to have a lot of loss per foot. This stuff, I think, is RG174, which isn't too bad. And again, I've only got 10 millimeters of it, so losses are absolutely minimal. Oh, should I have fitted this before I pushed the unit into the box? I think that may have been prudent. Let's take it back out and refit it. These IPX connectors are sort of things you get on laptop Wi-Fi antennas and the like. It should go with a little snap. There it goes. Wonderful. That has now snapped into position. Super. Right. That is back in position. Let's attempt to reconnect our SMA, which has got caught up there. There we go. Excellent. Next thing we need to do is the power. So, yeah, let's get on with that. Right, that's the power lead created. Now I do have to drill another hole in the box. So I'm going to use my plate again. And this is just a breather hole. Because I intend to seal all the big holes up. In fact, I've already sealed the antenna one. We need a hole that's just going to, you know, if the thing gets in the sun, the expansion of the air in the box is going to want to get out. And it will get out. And the way it'll get out is past the rubber seal on the lid. And you don't want that. So what we need to do is just drill a hole in the bottom of the box just to let the air in and out. Now, I've done a bit of research on this over the years. If you drill a hole smaller than about 3 millimeters, you won't get any water ingress problems. And I found this to be the case. So yeah, this is 2.5mm. I've got my plate so I don't drill through the battery, and yeah, we'll just there we go, and we just leave that open to atmosphere. That will let, you know, any changes in air pressure through, whilst still keeping it from getting wet. So that's ideal. Right, put my drill bit away. Okay, so if I was to connect power up to that now, it would now work. So that's good. There's something else I've got to deal with. The Paradar antenna comes with a really nice mounting kit. That is, you sort of slot the antenna into that saddle there, tighten it up from behind, and then it's supplied with some really chunky U-bolts that are going to bolt the whole assembly to the mast. Obviously, I've incorporated the antenna into the box, so this is redundant. And as luck would have it, this U-bolt is nothing like the hole pitch on the box, so I've got to drill those out bigger. And the problem is, you see that on camera. Let's have a little zoom in, shall we? See if we can get that a bit better. Oh. Yeah, there you go. If you can see that, the holes are only slightly misaligned, which means drilling them is going to be an absolute nose, because the drill's going to want to snag into the existing hole. So I think it's time to do the naughty and put the sacrificial soldering iron bit in and melt some plastic. Let's do that. I'm going to want the fume extractor on, and that's for sure. There we go. I need to swap my bit over for the one I use for burning plastic, which is that one that's black. And for those of you of a sensitive disposition, please look away now. There we go, that's going to work. I need to repeat the process for the other side, which has got the antenna in the way. Not the tidiest job in the world, but we have a winner, so I'm happy with that. Right, we need to solder that wire on. That will bring the Heltec to life. I need to put the wiring in and go and fit it to a piece of mast, which I've got to engineer as yet. But yeah, nearly there. Drilled my 2.5mm hole. I think the next thing to do is to put this wiring in. Bit of strain relief on it where it comes in, zip tie or something probably. Cover it in silicone so the wet doesn't get in. There we are, that's going in nicely. And then we're ready to go, aren't we? Most exciting. So yeah, oh, I need to identify which of those pins is ground on the Heltec. So meter to continuity, the ground will be shared with the USB and it's the end. Okay, so that's straightforward enough. That goes on like that, that goes on like that, in there. Let me get a zip tie. Unless there's one on the bench. Oh, there he is. Look at that. Snip that off. Put that in around there. Let's get a bit more silicone around there. Loads. Just gunge that round the back. Super. That's it. And while that's going off, I can go outside and move some brackets around and sort the mast section out. Well, that went better than planned. Yeah, the fixings I used, by the way, are called concrete screws. Look them up, they're absolutely outstanding. No raw plug or anything needed. And in fact, all the shelves that are above me here and in this workshop are all held to the walls with concrete screws. It's a masonry screw, needs no plug, just got to drill the right size hole, and they just bite in amazingly. If you've never seen those, go and have a look at them. Right, so I've got a piece of mast behind me there. You can see that? Yes, good. So the next thing to do is assemble everything, but obviously I need to reconnect the battery, which will start our unit up. And I do need to make one change to the configuration before I put it up on the mast, and that is just to make sure it can see the right bit of my Wi-Fi network, because yeah, at the moment I don't think it gets to that end of the house. Okay, see that on the camera, but the display has just lit up. Meshtastic. So I should pop the cap back on the battery. Beautiful. And I need to just send some configurations, so I will just do that quickly. Right, that's the configuration change. That says rebooting. Don't you see that? I doubt it. So it's just rebooting. I'll just make sure I can still reach it on the network in a moment. Yes, I can. So that's absolutely fabulous. Next thing I've got to do is just cut this seal so it seats nicely. There we go. And pop the lid on. Oh, whether I mentioned that earlier. I 3D printed a little Meshtastic logo, look. Go on the box. I'll link the files to all the battery holders and everything else I've built down in the description below. Well, those aren't the right screws. Those are the ones from the Heltec. These will be the right ones. Now I have to ask myself whether I actually trust the seal on this box or whether I should just run a little bit of silicone around it. And I think it's cheap insurance to do so. So I'm just going to put a smear of that around the seam of the box. There we go. That's sealed that up. And of course, being careful not to block that little 2.5mm breather hole in the bottom, because that will be bad. There we are. So that's currently online. We can supply it with 5 volts up that piece of lead. So yeah, next job really is to get it on the mast along with the weather station. So I'm going to stop here and go and read the instructions for the weather station, because I did read them and I believe it's got to point north. So yeah, let me go and do that, and I think I'll see you back outside. I've hit a bit of a snag. This is the mounting bracket for the weather station. The weather station is this Besser thing, 7 sensors, very good. Wife bought it for me for Christmas. Now, when this is, I failed to read the instructions, you see. Now, if you if you mount it to a mast, you're supposed to do this, you see. Put the little thing in there, sit the weather station on top, and yeah, that's how you mount it to the mast. Clearly, because I've got this on here, it's not gonna fit, is it? So yeah, that's not gonna work. So my intention was, you see, is to mount it on the mast like that. So mast is there, weather station sits here. Oh no, you can't do that because there's no 90-degree fitting for the end of here. That is designed to sort of mount it onto a roof straight down and have it on the top like that. No good. So what I've done is I'm just 3D printing a little adapter that's fit on the end, put our weather station on its little arm out of the one side. Hopefully that'll work. But yeah, it's delayed things a bit. Never mind, plenty else, other things to be getting on with. Well, I've made a little adapter, 3D printed, and I'll leave a link in the description below, despite that's not really the point of this video, but if you ever need something like that to make your Besser weather station stick out at an angle, there you go, little 3D printed 90-degree sort of adapter. Right, finally, let's get it outside. there you go. Our mesh node and weather station all mounted on a little mast. So yeah, let's go and enjoy the mesh. Thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you very soon here on Doz's Television Workshop. Looks like I've beaten the weather, just. At 863 megahertz, I think these are. Yeah, these are extremely popular. So ever so easy to flash. 868 megahertz. Let's do this again.